beautiful as they are in fact strange. So let's get started. This equation here, x squared equals 1, we can easily solve by taking the square root of each side. We know that x equals plus or minus 1. Okay, but what if I change the equation just a little bit? I have x squared equals negative 1. So we take the square root of each side. We get plus minus the square root of negative 1. Previously we were told you can't do that. That's undefined. We don't know what to do with the square root of a negative number. But now we have imaginary numbers. And the imaginary number is exactly that. It is given the symbol I, and it is defined as the square root of negative 1. So the solution to our problem here is now plus minus I, the imaginary number. And so I is a number when multiplied by itself equals negative 1. So I squared, which is just I times I, is equal to negative 1. And we can continue up to higher powers. I cubed is really just I times I squared. And we know I squared is negative 1. And so this is negative I. Now, imaginary numbers belong to a larger class called complex numbers. A complex number has both a real part and an imaginary part. For example, here A is the real part and B is the imaginary part because it is multiplying with I, the imaginary number. And what we're interested in is multiplying two imaginary numbers together. So let's introduce our second imaginary number as C plus ID. Fortunately, the FOIL rule that you've learned previously still applies here. So that is first, outside, inside, last. And that's exactly what we'll do here. Now, what I've done here is group the terms that have just one I in them, and that will be our imaginary part. And what happened to these last two terms here is, well, it ends up being I squared times BD. But we know I squared is equal to negative 1. So this will be a real number that we can combine with AC, which is also a real number. And there we have the result, or the product of two imaginary complex numbers with the real part and the imaginary part. So let's move on to our example problem, and I'll have to clear some board space so we can do that. So here is our example problem with the numerical values of the parameters plugged in, giving us this quadratic equation here, or the second order polynomial. We're given the solution to that, which you probably recognize as the quadratic formula. And what we want to do then is plug in our numbers, get the solution for values of s that make this equation equal to 0, and then take one of those solutions, plug it back into the equation and make sure we did it correctly by getting 0 equals 0. So let's get started with obtaining the solution values. We have arrived at our solution that s equals negative 1 plus or minus 2i. Now the I came from the fact that under the radical here we had 4 minus 20, which is negative 16. So we factor out the negative as negative 1, which the square root of we know to be I. And then of course we have the square root of 16, which is 4, and then divided by 2, giving us the imaginary part as 2i. So now we want to plug this value of s in back into this equation to make sure that this equation does equal 0. So obviously that's going to involve squaring s. So let's take care of that term by itself first. So we've just factored everything out, and now we can continue to simplify. Okay, so we found that with s equals negative 1 plus 2i, when we squared s, that the result is negative 3 minus 4i. So now we can take s squared, plug it in here, as well as add 2s and plus 5 to get our final answer to make sure we did, in fact, solve this equation correctly. So now we see that we have negative 4i and positive 4i, so that those parts will cancel. And then we have negative 3 minus 2, which is negative 5, and then when we add 5, this does in fact equal 0. So we get 0 equals 0, meaning this equation is in fact solved with the correct value of s. In the homework problem, you will test the other solution, negative 1 minus 2i, to make sure you get the exact same thing, because both values of s are solutions to this equation.